All right, welcome to this lesson. This is Unit 4, Lesson 4, Part 1, which is factoring the sum and difference of cubes. And I have a meeting I need to go to in about 20 minutes. So hopefully we can make this video in the 20-ish minute mark. So starting off with sum and difference of cubes, I wanted to start by breaking down the vocabulary. You guys know by this point that I often do that to make sure that we are really clear on what the words mean, so you can know when you're looking at this particular type of problem. So first off, the word sum, that's S-U-M, not S-O-M-E. S-U-M means to add, okay? So we're looking at things with a plus sign. So the sum, so we'll have two things, two cubes apparently. We're going to add them together. Difference, of course, we've done this before with the difference of squares, but difference means to subtract. So with the difference of squares, we only have a formula for the difference, only for the subtraction. If we're talking about cubes, then it will work with adding and subtracting both. So what are we talking about when we talk about cubes? Like, great, we're adding and subtracting these things called cubes, but what on earth are cubes? Well, when we talk about cubes, what we're looking or talking about are what are called perfect cubes. Okay, and now this is going to be related to the idea of perfect squares because math is consistent. So perfect cubes. So examples of perfect cubes. When we're talking about cubing something, what we mean is this. It is raised to the third power, okay? In other words, the exponent is going to be a 3. So an example of perfect cubes would be something like 1 to the third power, which is 1, or 2 to the third power. Now remember what that means. It means 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. Or 3 to the third power, which of course it's not 3 times 3, okay? If you're kind of going through stuff really fast, you're like, oh, 3 times 3. It's 3 to the third power, which means 3 times 3 times 3, which is actually 27. And you could also have, say, x to the third, because that is x times x times x. So when we're talking about cubes and we're adding and subtracting cubes, these are the things that we're talking about. Numbers like 1, 8, 27, 64. And so forth. So an example of a sum and difference of cubes problem, or sum or difference of cubes, could be something like x to the third plus 27. Okay, x to the third plus 27, that would be the sum of cubes. So you have x to the third, which is a perfect cube, and 27, which is a perfect cube. So that would be the sum of cubes. Or you could have the difference of cubes, and we'll have like 8x to the third power minus 1, okay? And everything in that expression is a perfect cube. 8 is a perfect cube, x to the third is a perfect cube, and 1 is a perfect cube. Okay, so that's what we're talking about. So we're talking about expressions that look like this, and we are going to work on factoring them. So there is a formula for this, and we called it soap sandwich. Square it, smush it together. If you'd like to see a video of that, I am going to link it in the video. Hopefully I can remember how to do that. Put the little card up. So for what this is, the formula. So I have taught it with the formula. In fact, every year that I've taught it with the soap sandwich formula. It's very mechanical, and I am going to link a video to that so you can see a previous year's video if you would like to check it out, especially if you really don't like how I teach it this year in this lesson. I just want you to know there are some other ways to do it, which are perfectly good ways. So there is a formula for that. This year we are teaching it using division, and there were a few things that went into that decision. So why are we teaching it this way? One reason is because students sometimes really struggle with formulas. So a formula is great and it can be efficient, but it can be it's like another thing to remember, another thing to learn. And we could do it using a strategy that we've already covered. We've already covered how to divide polynomials. So instead of teaching something totally different with a formula, why don't we just go with what we already know how to do, which is the division. Some of the other reasons, one, it helps practice that polynomial division. So it's been a while, at least this year. This is the first lesson after the break, and nobody remembers what we were doing a couple weeks ago. So it's going to get us back into that area model and that polynomial division. It helps reinforce the relationship between factoring and division. So if I were to ask you, what is the opposite of multiplication? You could answer the opposite of multiplication is factoring. You could also say the opposite of multiplication is division, okay? Both of those would be acceptable answers. And factoring and division are very, very closely related to each other, okay? They're very closely related. They're not exactly the same thing, but since they're both opposites of multiplication, you can tell they're close. And it helps reinforce the relationships between zeros and factors, or roots and factors. Remember, zeros, roots, x-intercepts, those are all synonymous. And factors, they are related to each other. We have talked about how they're related to each other, but it's an easy relationship to forget. And so by teaching this particular concept using division, it's going to help practice and reinforce some other concepts and skills that are important, as opposed to just jumping to a formula. So the steps in the process. Okay, so what are the steps? Graph the cubic to find the real linear root. So what we're going to do is use Desmos. We're going to graph the expression to get a piece of the answer. Okay, so we're just going to graph it and look at it. And obviously, I'll show you how to do that. Then we're going to change the root to a factor. So that's going to take a little bit of explanation. Then we'll do polynomial division to find the other factor, and then write the answer as factors. Remember, what we're trying to do here is factor an expression. That is, find the things that are multiplied, that when you multiply them are going to give us that expression. So we're going to graph the cubic to find the first answer, or first factor, well, root, and then change the root to a factor. Then do polynomial division to find the other factor, and then we just have to make sure we present the answer in the correct way. I would pause the video here if you're watching this from home, if you're absent in class or you missed the lesson, and write the steps down so that when you're doing your homework and you're doing the assignment that goes with this, you can have the steps in front of you so you remember what you need to do in what order, at least until you get it down. So we're going to start with this, and I think I'm going to lose part of. Yep, like it changes on my view is the moment I open up Desmos. So we're going to look at x to the third plus 8, which is the sum of two cubes, because x to the third is a perfect cube and 8 is a perfect cube. So when you're doing these problems, the first thing you really need to do is recognize, what am I looking at? This is the sum of two cubes. And then in Desmos, we're going to graph that, and we're going to look at the first answer. So this piece here is going to require a little bit of explaining. So if you look at the graph there, you'll notice that it crosses the x-axis at x is equal to -2. So what we need to remember is this. Okay, I'm going to actually work backwards. So if x is equal to -2, then that must have come from that equation there. So essentially what I did was I added the 2 to both sides. I added the 2 to both sides to get the x plus 2, which means that the factor had to have been x plus 2. And we looked at that when we were solving quadratics, and we would use the zero product property. You would take the two factors, set each factor equal to 0, and then solve it. Another way that you could kind of do that work is to say, okay, x is equal to -2, so we're going to add 2 to both sides, so x plus 2 is equal to 0, and then the factor that we have is the x plus 2. So that's one of the factors, is that x plus 2. The next step is to do the polynomial division. So when you have a cubic, when we set up the polynomial division, we are going to need 3 columns because it is a cubic. So you look at that exponent, okay? So I set it up. And I know one of the factors is x plus 2. So that is what I'm going to divide by. And then what I'm going to be looking for is the other factor. All right, so let's go ahead and do it. I'm going to put the x to the third right there. And most of you are pretty good at this. So x times what gives me x to the third? Well, that would be x squared. And then multiply to find this box right here. So x squared times 2 is 2x squared. Now, if I look at this, you'll notice that there is no x squared. Okay, which means that my x squared terms have to add up to 0, which means that this has to be negative 2x squared because they have to be able to cancel out. And that is a 2 right there. X times what gives me negative 2x squared? Well, that would be negative 2x. Multiply to get the middle square on the bottom. So negative 2x times 2 is negative 4x. And then notice again over here, there is no x term. Okay, there's no x squared and there's no x term, which means my linear terms or x terms have to add up to 0, which makes this 4x. And then x times what gives me 4x? Well, that'll be 4. And then 4 times 2 is 8. Now, here's something that when we do the division here, we're not going to deal with any remainders. And so if you get all the way to the end of the division problem and you get the number that matches, it serves as a check. Now, remember what the directions were. The directions were to factor. Well, we got one of the factors as being x plus 2, and the other factor is x squared minus 2x plus 4. And we're done. Ta-da! So what we have done is we have taken x to the third plus 8, and we have factored that into x plus 2, which is one factor, and x squared minus 2x plus 4, which is the other factor. And we're done. As long as the problem is just asking us to factor, then we have got it factored. And I like the strategy. You know, I can probably do it faster using the formula, but that's because I've got experience using the formula. For you, it might be a little bit different. So there's the first problem. If you need to pause the video here to kind of look at that or rewind the video, get another explanation for it, now is the time to do that. Okay, so here's our next one. And this one, we have x to the third minus 1. So our first step is going to be to graph it and find that first root 0 x-intercept. So we're going to use the graph to get the first one. Now, x equals 1 is the 0 that we can see. I'm going to subtract 1 from both sides to get x minus 1 equals 0, and that tells me that x minus 1 is one of the factors. So that solution of x equals 1 came from a factor of x minus 1. And now we'll do the division. So it is a cubic. So because it is a cubic, we will use 3 columns. And we're going to be dividing by x minus 1, and we're looking for the other factor. So in the upper left, we have x to the third. X times what gives me x to the third? That would be x squared. And then negative 1 times x squared is negative 1x squared. And this will work out this way for all of these problems where there is no x squared term and there is no x term. And so makes it pretty easy here where you know they need to cancel out. So it's going to have to be positive 1x squared. X times what gives me 1x squared? You could say 1x or just an x is fine. This would be negative 1x. When I multiply it. And again, there's no linear term, which means that they had to cancel out, which will give this to be a 1x, which means that is a 1, and 1 times negative 1 is negative 1, and you should see it match. Last step is make sure you write it as factors. So the factors were x minus 1 and x squared plus 1x plus 1, and I'm just going to write x there. And we're done. Okay. So again, pause the video right here if you need to see that again, get the explanation again. Okay, so here's one for you to practice on. Pause the video. If you're doing this from home, pause the video and just try to work it out, see what you get, and then unpause the video so that we can check it together.